Hello friends and welcome at my channel. Today I would like to show you guys how to compute the points of inflection of a graph, and we make a comparison between points of inflections and max and means. So let's start with the geometrical idea, which is very helpful in this case. So let's imagine we're dealing with such a graph, all right? And we have maybe a few more curves. Let me put it differently. So let's do it like this. All right, one, two, and maybe a few more. So you see, maybe now we have the max right here, and then we have a min right there. And if we look at the tangent lines that we are putting on the graph, you will see that, well, right here we have the slope of 0, which is also the same here. So we have 0 and 0. In between, we are falling down, as you can see. So the graph goes deeper down, deeper, even further deeper. This is actually the point where our slope is the biggest. So this is the steepest direction downwards. I don't know, maybe it's -3 or something. After that, after we have -3, we start increasing again, and at the end we are at 0. So the point where we are right here is the point with the smallest slope. Well, the absolute value is the biggest, but actually the value, if I give you an example of -3, is the smallest, all right? This is the first observation we have. Let us see what's happening in the next interval between the mean and the max. You see here the slope once again would be 0. Well, let's call it maybe even m1, m2, and m3 in order to distinguish those 3 points where we are. And now you see maybe what's happening here is we are starting with 0, and we are increasing a little bit more, a little bit more, and then we're here. That would be the point with the biggest slope, and after that we are decreasing. We're getting smaller, smaller, and 0. So we got 2 points. The first one, this one, with the smallest slope in the interval between max and mean, and the second one, this one, with the biggest interval between mean and max. Now, let's now be a little bit more precise in the first case. So let me just take this one where we are. So let me just take a piece of a graph now, like this. And now let us think what's happening, well, somewhere here. As you can see, we are at max right there. We're falling down, we're getting smaller, we're getting smaller. We're having the smallest value here, but this is not the only point that we're mentioning here. After that, we're increasing, we're getting later to 0, that's fine. We know that already. But what is interesting here is if you look at the curvatures of our graph, you will see a very interesting fact. Well, you see, so our tangent is just parallel to the ground right here. The next one I was showing is this one, and you see the direction between this one and that one is kind of to turn it like leftwise, to put it to the left, all right? Just go with me through this. So if you have a steering wheel, you just put it to the right. So, I mean, I'm turning it somehow. And then I'm putting the next tangent line here, and you see we're still moving this way. So I said right, no. So yeah, I'm turning it to the right. If this is a steering wheel, I'm turning it to the right. Well, it can be confusing. It's not about left or right. It's like in physics, you know, what is the charge, positive or negative? It doesn't actually matter. The point is we have to distinguish between those two. We have to understand that exactly here, what's happening on the curve is after we pass this point, the situation is changing. Now the tangent lines are not going to the right anymore. On the contrary, they are trying to go to the left. See what's happening. If I'm putting this one and that one, and the next one. You see what's happening with the tangent lines? They are actually moving away. So now they're going into the other direction. Now I have to take the steering wheel and put it to the left. So this is exactly what's happening. So this is why we call these points the points of inflection. What's happening there, the curvature is changing. So we had it direct pointing to the right, and after we pass this point, we are then moving to the left. All right, so this is what's happening. And what is interesting as well, we've seen that at the same time, this is the point where the slope has its smallest value. This is very interesting. So this is a very interesting observation. This is the point where we have at the same time the smallest value of the slope and the change of the curvature. You see that? That's very important. And what's happening here? Well, exactly the same. You see, the tangent lines are still moving. They started to move to the left from this point on, and they do so until this new point of inflection is coming. After that, they decide otherwise. They decide to go to the right. See what's happening here? After that, everywhere they're moving to the right, previously to the left. And this is once again, so the point of the change of the curvature is the point with the biggest slope on the interval, and this is the point where we have the change of the curvature. Okay, so biggest slope, change of the curvature, or the smallest slope and the change of the curvature. Now, let us remember from the previous video in this playlist how we computed the max. Well, basically we took f of x, we computed its first prime, we set it equal to 0, and then we moved to the second derivative, and we wanted to know that, for example, the value is positive. I told you it's showing us what's happening afterwards. Afterwards, we're going up, so that means we've been down previously. That means we have a min. If the second derivative would be negative, that would mean after the point in both directions we would go down, so we must have been up, and that's why it would be max. And if you remember, I hope that you remember, please don't forget it, if the second derivative is also 0, we cannot say anything about max or mean. We have to work with tangent lines slightly previously and slightly behind just to see what's happening. So this is exactly the idea, all right? We have to deal with that. So since our points of inflection are the points with the max of slope or the mean of slope, this is a very interesting connection right here. So once again, let me write it down. F of x, we're considering this one. We take the first derivative, we put it equal to 0, and then we switch to the second derivative, and we want it to be bigger than 0 or less than 0, but not to be 0, because if it's 0, we have no clue. So that means it should be just unequal to 0. If that's the case, we have the extreme value. Extreme value. Extreme value. That's for sure. Okay. All right. All right. So we have extreme value. And then we move on and we say, well, since we know that the point of inflection is the same, so it's extreme value, but for the slope, which derivative is corresponding for the slope? Well, the first one. So we are taking f prime of x, and we are moving to the next prime, to the next derivative, which is the second derivative. We are putting this one equal to 0, and what we only have afterwards, we only want to have the third derivative to be unequal to 0. That's it. If we have this, then that would be an extreme value of the slope, which is point of inflection. That's it. Point of inflection. So this is what you have to understand here. And let us quickly compute an example. So let's take f of x being equal to, well, let's say x cubed minus x. All right. So what is the first derivative of this guy? That would be 3x squared minus 1. What is the second derivative? That would be 6x. Well, that's pretty easy. Putting 6x equal to 0 means x is equal to 0 itself. And the third derivative, well, it's just 6. It's never 0, especially if we're putting 0 for x. It's still 6. It's unequal to 0. So that means we have a point of inflection. And if you look at our picture, of x cubed minus x, well, x cubed minus x is no big deal. We can take x out and we have x squared minus 1, and that would be x. And now using binomial formulas, would immediately show you 3 0 points. 0, minus 1, and 1. It's a positive factor right here, so we're going up. That means it looks like that. And as you can see, that's true. At the origin, at 0, we are changing our curvature. And we have the smallest slope, by the way, because it's decreasing at the steepest value. But as you can see, our tangent lines are trying to escape to the right. After that, they're trying to escape to the left. So that seems to be correct. Thanks for watching, guys. See you in my next video. All the best. Bye-bye.